Welcome back. Today we're going to be starting Unit 9, which is all about functions. First, we're going to talk about identifying functions and their domain and their range. Before we get started, we're going to start with a couple of different vocabulary words. First word that we're going to talk about is a relation. All a relation is the pairing of input, and input are the x values, and output values. The output of y. Our relation is a list of ordered pairs, points. You plot a bunch of points. It's a series of pairs of x's and y's, and that's all a relation is. Now, within a relation, we could talk about the domain. The domain of the relation is the set of input values. Then, input values are going to be equals. So the domain just has to do with all of the different x values. So that's talking about the input. And the range is exactly the opposite. The range of the relation is the set of output values. So the range is set the y values. Now, some relations can be functions. Okay. Now, a function is a relation that passes the vertical line test. And I'll explain what the vertical line test is in just a second. As a relation that passes the vertical line test, okay, which means there are no points of one another. Each other. So basically, if a relation is a function, it passes this vertical line test. In order to pass the vertical line test, you cannot have any points directly above one another. So for example, 1 and 2 determine if these following relations are functions. Without doing this vertical line, only the graph tests this function. So this relation twice. If I have points one another above one another, that means it would fail the vertical line. In order to be a function, you have to pass. This relation is not a function since it fails the vertical line. Let's move on to number 2. Now, number 2 is just a quadratic. Now, if I were to draw a vertical line here, how many times does my vertical line touch my relation? Just one. Now, you might think it would touch more than once here, but actually my quadratic keeps on getting fatter and fatter and fatter. So, since my relation only touches my vertical line once, and again, I could have multiple vertical lines, right? So, you would only touch once each time vertical line. So, this would be, yes, it's a function that passes vertical line test. Right. Oh, I forgot to circle. Yes, this was a function. No, this was not. All right, so now we're going to talk about the domain and range. Remember, the domain are the axis, and the range is the y. So remember from unit 2, we start by writing the curly brackets and stop the domain. Now, the x-axis, it goes left to right. So we're going to look going all the way to the left and all the way to the right of my function. See how the left has an arrow? That's going to keep going. Okay. To the right, that's going to keep going. The domain is going to be all real numbers. Remember this symbol right here? So like write two L's and then do an R. This means all real numbers. You either write the symbol or you write all real numbers. Okay? Now the range, and we're going to start it pretty similar with the curly bracket, but the y next one. The y-axis goes up and down. So I'm going to look at the function. Will my function go all the way up? Yes, because there's an arrow going up. Will it ever hit down here? And the answer is no, because if you notice, my x, it's called an exponential function, is getting super, super close to that x-axis, but it actually never touches it, it gets really close. Well, if you look at the x-axis, the y value, it gets really close to 0. Since it's above 0, we use greater. My range is y is greater than 0. For example, if my exponential function was up here, see it's getting close to 1, it would be y is greater than 1. It's 0 because it's getting close to the x-axis. Alright, let's go ahead and move on to number 2. Again, so we're going to start with the domain. I'm going to start with the current bracket. And again, I look at the x-axis that's going left to right. So does my function go all the way to the left? Yes, because the arrow is going to keep going. Does my function go all the way to the right? Yes, because it's going to keep going. So my domain is all reals. Alright, let's start with the range. Again, I'm going to do a curly bracket, y, colon. Remember, my y goes up and down. So I'm going to look, will my function go all the way up? Yep, because it's got that arrow. And will it come all the way down? Yep, because it's got that arrow. So my range is also all real numbers. Okay. Alright, let's move on to number 5. Then we're going to start by doing the curly bracket, x, colon. Let's go ahead and look at the x's. So does my function go left to right? Basically, if it has arrows on both sides, which it does, it's going to be all real. Now my range, this comes out. Again, there we go. See how my arrows are both going up? I'll never get down here. Where is my lowest point? This point right here is 1 comma negative 2. Remember, it's always x comma y. So I'm going to be working with this negative 2 since my range is y. Since they're both going up and it touches, it includes negative 2, it's going to be greater than or equal to negative 2. Alright, let's go ahead and move on to the back of the notes. We're going to be working with identifying different types of functions. It's all the functions that we already graphed. So the first one, it's a line, basically linear function. The second type of function, it's a U-shaped graph. It's called quadratic function. With a U-shaped graph, it's called parabola. And lastly, we have exponential functions, which are kind of in the shape of the backwards L. Remember, they get really close to the x-axis, but they never touch the x-axis. Alright, so what we're going to do is we're going to graph some different functions, identify them first, and then write the domain and range. So let's look at number 6. I have f of x. Remember, I'm using function notation. If I'm using function notation, I automatically know it is a function. So meaning the relation is going to pass the vertical line test. Okay? 2/3 x plus 4. Remember, if it's a quadratic, I'll have x squared. And if it's exponential, my x will be in the x. If it's linear, it's just going to have an x. Remember, this is an x to the first, so it's linear. The slope, remember the slope is an x plus b, so the number attached to the x, which is 2/3. The y-intercept is always 0, or whatever this last number is, 4. I like to use the domain range at the very end. So I'm going to start by graphing my slope at y-intercept, so 0, 4. Since my slope is positive 2, 3, I'm going to rise 2, and then go to the right 3. 1, 2, 3. I'm going to rise 2 and write 3 until I cannot go any further. Run, remember, is always to the right, unless you're going backwards. So I have to get points down here, so I'll be going backwards. So fall 2, left 3. Fall 2, left 3. Fall 2, left 3. Go ahead and connect it. And add arrows. Now see how I can use function notation? If I jump a bunch of vertical lines, they'll only touch my line once each time. So that means it's going to pass the vertical line test. Alright, so let's go ahead and start talking about the domain. My domain are the x values. Again, if you have arrows on both sides, your domain is going to be all real numbers. It's going to go all the way to the left, or it's going to go all the way to the right. Alright, the range, again, start with the brackets and the y, colon. Again, look, we look at us going up and down. Will this line keep going down forever? Yes. Will this line keep going up forever? Yes. But since I am past both of them, my range is all real numbers. Alright, let's go ahead and move on to number 7. 7, the type of functions. You notice that the x is in the exponent. So this type of function will be exponential. Let's put backwards L back. And remember when we graph an exponential function, I have 0 first, -1, and 3. Now to find the y values, then we're just going to substitute them to the x. So your calculus is 3 to the -1. That's 1/3, which is equal to 0.33, just so you know how much to go off the y-axis. Now 3 to the 0, remember anything to the 0 power is 1. And then 3, oh sorry, this shouldn't be a 3, this should be a 1. 3 to the first is 3. So plot that, be -1.3, so it's there, 0, 1, 1, 2, 3. Now let's say if you're unsure if I went below the x-axis, go ahead and put -2 in here. That would be 1/9, which is even smaller. So I would get even closer to the x-axis. If you keep going more and more negative, again, it's going to keep getting smaller and smaller. We're going to graph our exponential function like this. Again, do not touch that x-axis. It gets really, really close to it. The domain of arrows on both sides, right? I should keep going to the left, so we'll keep going to the right. Yes, this domain is all real numbers. My range now, again, I'm going to go all the way up. That arrow is going to keep going up. But will I touch that x-axis? No. That's my graph. My backwards L graph is above the x-axis. It's going to be greater than 1. Well, I'm getting close to this right here, which is 0. Alright, last example. Number 8. Notice the exponent is 2. That means it's going to be a quadratic. Now this is from last unit, so if you remember the third text, is always the opposite number inside, so it's 3, same number on the outside, 2. The axis essentially is going to be always x equals, so there's an equation of a vertical line, x equals 3. We'll talk about the y-intercept and the x-intercept once I stop. Remember, 3, 2 go in the middle, so that's the vertex. We go too small, too bigger. We're going to substitute all these numbers, 1, 2, 4, and 5, back into your function. I'm just going to tell you those values now. It's 6, 3, 2, 3, 6. Notice they are mirror images of each other. That's because it's going to be symmetric. Let's go ahead and plot this. So I have 1, 6, 2, 3, 3, 2, 4, 3, 5, 6. Again, it makes a U because it's a quadratic. Now, let's skip the y-intercept. Let's go ahead and do the x-intercept. Do I have any points on the x-axis? No, there are none. Domain. Do I have arrows at both sides? Will this keep going to the left? Will it keep getting fatter? Yes, we'll keep getting fatter to the right. Yes, my domain is real numbers. Now my range. As I look at the vertex is 3, 2. Number 3 is the x, 2 is the y. So I'm going above 2. So I start at 2 and get bigger. So that's going since I touched 2, it's going to be greater than or equal to 2. Also, having found the y-intercept, remember, if you have a point on the y-axis, that means x is 0. So in my function, I'm going to put 0 in place of x and solve for y. So negative 3 squared is 9 plus 2, which is 11. My y-intercept is 0, 10. And notice it would be up here, but my graph stops at half to 10. All right, please go ahead and stop the video and complete your homework.